now I will be reacting to and do its cut because I'm not that voice because people just doing this. Aqua notes pero sini orange pero what? So we say porous aerosol or whatever you call it, airplane brand, I think, yeah, covers the remote. I don't know what it's called. Okay, this is Sorinia Lara Terra. Empty band. I don't know if okay. I guess that's it.
Have you ever wondered how much water? Easily Google the answer. It's 332 million cubic miles. But the problem is that this number is simply too big to imagine. We've nicknamed the planet the Blue Marble because when viewed from space, the water is overwhelmingly visible. 2/3 of the surface is covered in water. But that doesn't begin to tell the whole story. So in this video, I wanted to see just how much water there really is and whether or not we're going to run out of it. If you could remove every drop of water on Earth and form a sphere with it, how big would that sphere be? Now, you might be thinking that it would probably be larger than the moon because we have a lot of water and the moon's not that big. I mean, look at it. It's literally just sitting there on the Earth. Yeah, good sit. All right, so what size are we talking about here? It would be this big, which might be a little smaller than you're expecting. However, what you are seeing is all of the water on Earth. All of the oceans, lakes, rivers, glaciers, aquifers, clouds, and even the water in all living things. It all forms a hydrosphere small enough to be a moon of our moon. But how is that the case? How is it possible for that tiny little sphere to cover so much of our planet in water? Well, the answer is that the Earth is relatively flat. No, I mean that it's smooth, not flat. You see, Earth may have very deep trenches and giant mountains, but compared to the width of the entire planet, the difference between them is basically nothing. You may have heard that if you were to shrink the Earth down to the size of a billiards ball, that it would actually be smoother than that billiards ball. In truth, however, that's a little bit of a misconception because the Earth would actually feel closer to 320 grit sandpaper, but let's be real, that's still pretty dang smooth. Plus, a little bit of water goes a pretty long way, as anyone who's ever spilled a glass of water certainly knows. Even a small volume of water can cover a really large area, and that's exactly what happened here on Earth. If Earth was the size of an apple, the oceans would be 7 times thinner than the skin of that apple. Now, don't get me wrong, that is still a lot of water, obviously. I mean, yeah, it's 860 miles wide, but that means it's also 860 miles tall. That is 3 times further out into space than where the International Space Station orbits the Earth. But what is all of that? How much of it is freshwater versus salty ocean? Not much. Only 2.5% of all water is fresh. However, if you were to gather only the fresh water, it would still form a sphere 250 miles wide. That's twice the width of Florida, so take that, Florida, I guess. Here's the thing, though. Yeah, it's fresh water, but that doesn't mean it's drinkable liquid fresh water. Most of that is ice. You see, 61% of all fresh water is actually frozen in the Antarctic ice sheet, which is a massive plate of ice the size of a freaking continent. If you were to separate all of the ice from the freshwater sphere, it would look like this. That's a pretty hefty snowball. So where's the rest of the fresh water? Well, most of it is actually underground, and I'll get back to that in a moment. Obviously, we have lakes, rivers, clouds. Oh, permafrost, which is just frozen dirt. We actually have 3 times the amount of permafrost than we do in all of the lakes combined. Freaking frozen dirt. FFD. Jesus. In fact, of the world's freshwater supply, lakes and rivers only account for 0.3% of it. That small little ball meets most of the freshwater needs of humanity, and all of life for that matter. It is about 35 miles wide, and at this scale, you can now begin to see individual cities. But that sphere also contains all of the world's freshwater rivers as well, and we're talking, the Mississippi, the Nile, the Yangtze, the Amazon. They only add up to 2% of all surface fresh water and would form a sphere a mere 10 miles wide. To compare, there is 6 times that amount of water in the air around us, and some of that is in the clouds, sure, but most of it is actually in the water vapor that you can't even see. It's invisible. Now get this though, you and I, we're mostly made out of water, but that goes for every single animal, plant, bug, even bacteria. If you could remove the water composition from every living thing, it'd be half the volume of even the rivers. Okay, now remember when I mentioned that most of the water is underground? Well, if you were able to extract all of that, it would form a sphere 160 miles wide. However, we can only really use about 6% of that water due to a number of different reasons like accessibility and renewability issues with the source. The average American, for instance, uses about 90 gallons of water per day, which is 18 of these classic-looking water jugs. And of course, that's divided between things like flushing toilets, bathing, cooking, washing, etc. It all adds up. However, where we really use our water is indirectly, by eating it. We don't directly see it, so food, for example, uses a lot of water to produce, and beef in particular. A single pound of beef requires 1,800 gallons of water, which is 360 of these same water jugs. And I realize that might be hard to believe because it doesn't seem physically possible, but don't forget that cows, they eat a lot of corn, and all that corn requires a lot of water to grow. It's kind of seeming like that much water to go around, and yet humanity uses a lot of water. So are we going to run out or not? And the short answer is no, but there's not an actual simple answer to this question. It is estimated that humanity uses 4 trillion cubic meters of water per year, and that comes out to a sphere that's about 12 miles wide. Every year. See, the real problem here is water scarcity, not whether or not we're gonna run out of it. There's a lot of water left. The original point of this video was just to kind of show how much water there is on Earth. I thought it'd be some sweet visuals. I didn't even plan this part of the video. I haven't written anything for this. I'm just kind of talking now. So if you're wondering what kind of things you can do to help this problem, well, the first step is simply to be mindful of your water usage. I'm not asking you to become vegan. I'm not vegan. I love beef burgers. However, that being said, I've kind of fallen in love with the Beyond Burger. It's plant-based and uses 99% less water than its beef counterpart, and honestly, it's really hard to tell the difference. The one from Carl's Jr. is pretty solid. This isn't sponsored. I'm just saying. So yeah, I'm just simply asking you to be more mindful of this as a problem. Maybe share this video with your friends. Yeah, I'm just glad you watched it. I'm tired. This video comes out tomorrow, and we're doing a merchandise push. Check this out. Over at Quarter Digital, that store, we put this really cool hoodie up for sale. Have you seen those videos that show the scale of our universe? They're pretty neat because they demonstrate just how in our galaxy are than our own sun. However, my problem with these videos is that we quickly lose context of scale because as each new star is introduced, they appear visually the same as the one before it. So we're just kind of left thinking, yeah, I guess we're pretty tiny in the scale of the universe, but I want to know just how tiny we are. So instead of using a scale that changes, in this video, it's going to be locked. And just like you can have miniature scale models, our scale is 1 to 190 million. That shrinks the universe down to a point where the Earth is the size of a tennis ball, and that makes the moon the size of a Nerf ball. Now ask yourself this question. How far away would they be from each other?
Elbows bent just a little bit here.
Right here, I'll tidally lock it. Because it took the astronauts 3 days. That'll do. There. Here.
Actually, our little moon would be all the way over here, 7 feet away. The real moon sits 250,000 miles from the Earth at its furthest point in orbit. And here's a fun fact. If you were to line up each planet in the solar system right next to each other, they could actually fit between the Earth and the moon. Next to Earth, we would put Mercury, Venus, and Mars, and then expand outwards to Jupiter, followed by Saturn, and then Uranus and Neptune. And you could even throw little Pluto in here for good measure. It's just crazy that they actually fit there. And if you want to read more about this crazy cosmic coincidence, I've linked a really interesting article by astronomer Bill Plate. As you can see, even at this scale, Jupiter is pretty big. You could fit 1,300 Earths within the volume of Jupiter.
Hey, what's up?
It's nothing compared to the sun.
I see one drink. Can I have one sip? Only one sip. Okay.
Now, at this scale, the sun would be half a mile away. So for simplicity's sake, I'm just going to put the sun right here. It's so bright. Okay, let's not actually simulate the brightness, too. Let's bring that down. Okay, that's better. At this scale, the sun would be 24 feet wide, which is over half the width of this whole street. In fact, it's so big, the sun can fit 1.3 million Earths inside of it. That's pretty crazy. Now, our sun is actually larger than most stars. As a yellow dwarf, it's bigger than 80% of the stars in the entire universe. Most stars are red dwarfs, and they're about half the size of our sun. But even if the sun is above average size, it's certainly not the biggest. Let's look at Sirius. No, not Sirius Black. That's Sirius. It is the brightest star in the night sky because it is only 8.5 light years away, combined with the fact that it is 20 times brighter than our sun. You can even see Sirius in most light-polluted cities. Now, a quick side note about these comparisons, I'm simply focusing on the diameters of each of these stars. And that doesn't necessarily correlate to how much mass a star has or how bright they appear, because some of these stars have
Okay, I don't know.
such a huge
Okay, never
volume
mind.
that they appear absolutely massive. Arcturus is 26 times larger than our sun, yet it isn't even twice as heavy. At our
Okay, yeah,
tennis ball
goodbye,
scale, it is
guys.
600